To each and every one of you joining us today for the Tech Symphony webinar in electronics organized by the Electronics and Computer Science Club at University of Kelaniya. Today, we are honored to have a very talented personality who has mastered in this field, and he is the perfect individual to lead this transformative event. So, I cordially invite Dr. Jehan Senevirathna, Senior Lecturer, Department of Physics and Electronics, to conduct the session on the future of autonomous vehicles. I warmly welcome you, sir, to share your valuable insights and experience with us here.
Thank you, Nuanshi. So if we look into this particular aspect, right, of autonomous vehicles mainly should take you from one place to another without your involvement or a driver's involvement or human driver. Right? Even we are not looking into a robot driving it. The vehicle itself should take you from one place to the other. You just need to take the vehicle where to go, right? Based on that, the vehicle should take you to the destination. So that's the kind of whole idea about the autonomous vehicle. So remember, even though I have everything in images, everything will be like cars. Autonomous vehicles is not just cars. Okay, so keep that in back of your mind as we proceed. So if you imagine a world dominated by autonomous vehicles, what type of an image comes to your mind? Maybe you can take a few seconds to just think about it, how it would be. Right? Maybe you have seen AI generated images, probably you have seen some illustrations by artists. Right? But yeah, in your own view, what would be the world of autonomous vehicles, like a world dominated by autonomous vehicles? Meaning you have autonomous vehicles, more autonomous vehicles than the normal day-to-day vehicles that you would see today. What would be your vision into maybe 2035, maybe 2050? The world of automobiles, right? World of autonomous vehicles. How it would be? Probably you might have seen images like these. Right? It's not only the vehicles, even the atmosphere would have changed. In my imagination, the image will be a little different. One specific reason would be I would not be having this much of people on the pedestrian crossing or pedestrian, not crossing actually, pedestrian walk or the sidewalks. Because if you imagine into 2035, most of the people would be working from home and people might be traveling mostly for leisure purposes. That's my opinion. Right? So things might change. You may not see. I mean, even here you see that there's not much of vehicles on the road. I mean, compared to a city like this that you imagine in 2035, I agree on that. I mean, you might not see this much of private vehicles on the road. But the number of people on the road or in the sidewalks, I would say that would be reduced. That should be reduced. This needs to be a reality. That's my opinion. On top of that, you see that there are some flying objects. Yeah, why not? I mean, if you look into vehicles nowadays, they are like kind of hybrid vehicles, not in the sense of power management or energy management. Yeah, we have hybrid vehicles nowadays, so-called vehicles that have engines working with electricity as well as gasoline or petrol, the terminology that we use in Sri Lanka. And we are working on autonomous vehicles as well as we are working on renewable energy consuming vehicles, even for heavy vehicles like container trucks. So all these are happening. So not to get confused, autonomous vehicles are not EVs. EVs is a different scenario. Autonomous does not necessarily mean that they should be EV or electrical vehicles. Okay. But we see the tendency when we talk about autonomous vehicles, we just have that tendency to go towards EV as well. Right? But don't get confused that when we refer to the term autonomous vehicles, it does not mean that they are electrical vehicles only. Okay. So whatever your imagination was, is really important for you to imagine the things, right? I mean, then only you can kind of perceive and kind of cross-check with whatever going around the world, tell your mind maybe it thought it differently. If we look into the history of autonomous vehicles, I would say we in as Sri Lankans, we had autonomous vehicles about a century ago, maybe more than that. I have witnessed autonomous vehicles when I was in, when I was like 5 years old. When I was about like 12 years old, I didn't see this type of autonomous vehicles much. Nowadays, I hardly see this type of autonomous vehicles. Probably you might see day to day if you were in your village. By definition, right? According to the definition, this is an autonomous vehicle too. Right? Why it becomes autonomous? Because I have seen that people get drunk. The people who kind of own these bullock carts, they get drunk and just lay down. I have witnessed with my own eyes, and you can ask your parents or grandparents. The owner get drunk and just lay down, and the dogs or the bullock cart dogs and ox will so they will take you home, and the owner they will take the owner home automatically. Right? I mean, doesn't need to control at all. And I have seen that. So by the definition of autonomous vehicles, this is an autonomous vehicle, but we will not consider it as autonomous because we don't see electronics there. We don't have those connections, controls, the modern sophistication there. But in my opinion, that's type of an autonomous vehicle. And I mean, you may not agree with me. Anyway, but if you look into autonomous vehicle evolvement, right? Evolution in a way that anybody in science or engineering would agree upon, you can see it in different levels like this. Like the zeroth level, nothing is autonomous, right? Level one, probably one thing is autonomous, right? Probably automated braking or emergency braking. Level two might be maybe two things getting automated, multiple stuff. And level three, now this is according to SA International publication. SAE is a well-renowned organization for automation, automobile especially, right? This is automation engineers. So level three, it's like could do some maneuvers like object avoidance, likewise, right? And then level 4 would be not just one vehicle we are talking about, probably one community getting involved in autonomous vehicles, and that your autonomous vehicle could kind of navigate along that community. For example, back in the days, even in 2014, something like that, the city of California kind of trying out these things. And I got to know from Professor Ranavir a couple of years ago, even South Korea tried out some taxis, autonomous taxis in their cities. Right. So likewise, in limited areas, the level 4 is like in limited areas, the vehicles that could be operating in limited areas. And level 5 would be, I mean, it's not kind of restricted to one particular automation. It's not restricted to one particular region that you can operate those vehicles, and you can go many places with those, right? Destined places, for example. If the vehicle is capable of taking you from one point to the other, if it's not off-road, right? Or if the vehicle is not recommended for off-road, I mean, you could not go off-road with the autonomous vehicle as well. But if that vehicle is designated for including on off-road driving, then your autonomous vehicle should be able to go to a hilltop as well. I mean, off the road and then detect everything, determine the climb, the movement, probably animal encounters, right? We have to train for those. So that is the world that we are kind of imagining. As can you remember, I was telling, I just told like about a couple of minutes ago that what I look for in the world in about 20 years from now is mostly people commuting for leisure purposes only. Right? All the other stuff will be delivered. And for those as well, delivery as well, you might need autonomous vehicles. Okay. So think about that. So autonomous vehicle demand may not go down, but the use of vehicles in 20 years time might be very, very less than what we think that it would be. Right? That's my opinion. But I had this opportunity to join a conference in 2014 in Colorado. This was regarding energy related conference, but in this conference, they were mostly talking about autonomous vehicles. They were leading manufacturers like GM, and they actually had plans. And they told us they had a plan to have fully autonomous vehicle fleet or have vehicle automation, especially cars being automated, fully automated, like autopilot mode, 100% by 2050. But back in the 2014, they also mentioned that that was their initial idea, and by 2014, their prediction was like 2035, 15 years in advance, because this area, automation, right, and also specifically automobiles, cars, that's a highly controlled domain with the industry giants. Like industry giants basically control whether you're gonna see an electric vehicle, um, electric vehicles coming into the market a boost or not. Right? They may have the technology, but they strategically will not introduce the technology until they hit the sales targets. Right? So it's a different domain when it comes to automation and specifically automobile, autonomous cars, autonomous vehicles. This falls into heavily automobile. So automobile industry, as I mentioned, is heavily controlled by the industry giants. So if they have this vision 2035, it's highly likely that we will see autonomous vehicles coming into action uh, very soon. Right? We see it already, but we will see throughout the course of this particular um, discussion or a webinar whether what is actually holding this autonomous vehicle being kind of a dominant factor or kind of having a significant boost. Okay, so I will put in another opinion of mine in terms of this level 0 through level 5 that is published by SAE International. Right? I would say in between level 0 and level 1, so-called like autonomous braking, there were many other small steps that were leading towards autonomous vehicles. Right? Two important things would be, in my opinion, right? Self-canceling turning signals. I mean, that is nothing electronics. It's mainly mechanical. You turn on the signal light towards left-hand side. You just turn the steering wheel towards the left-hand side, and the moment that you just release it with the power steering, of course, if your vehicle has power steering. So after power steering was introduced, only self-canceling turning signals were dominating, right? So once you just kind of release the steering wheel, and it automatically comes, or you turn it back again to the straight position, straight on position, then the signal light will turn off automatically. You don't need to kind of turn it off. Yeah, it's mechanical most of the time, most of the vehicles. And modern day vehicles, some are electronic. However, that is some sort of an automation, a single very tiny little step. Another one would be auto rain sensing wipers. So when you detect rain, you just automatically turn on the wipers. Not only that, it's not just only turning on, and it has the capability of adjusting the wiper speed according to the heaviness of the rain. Right? So we have come up to that extent. So don't we need that type of a feature in autonomous vehicles? Definitely we need. Right? In autonomous vehicles, we would want to have. Why? I mean, there's no driver to kind of visually see the stuff. But there are cameras, right? There are cameras embedded in autonomous vehicles nowadays. So we need a clear vision for the camera. So we need wipers for those as well, like those autonomous vehicles as well. On top of that, in autonomous vehicles, anyway, there will be passengers, occupants, right? So the occupants or the passengers would love to see the outside. So we will need wipers. So it's kind of another step towards automation, in my opinion. If you look into the history of automation, I think we should consider those tiny little steps as well. Right? Another very important thing, in my opinion, is cruise control. Remember, this cruise control, one might think it is kind of autonomous. One may think it's not autonomous. So if you look into cruise control, the idea is you just get to a speed. Usually there's a minimum speed that you can have, right? Um, and a maximum speed, obviously, due to restrictions or the limitations of the vehicle. So once you accelerate up to a certain speed, you can just press the cruise set or cruise on button, right? And then you set the cruise. That speed will be maintained. And these type of technologies were there in 1990s as well. So the vehicle will communicate with its control system and look into the speed. If the speed is high, then it will be slowing down, right? Braking, and even engine power will be reduced. And if you are climbing up a hill, then automatically, not automatically, I would say naturally, your speed will be going down. So in that case, you will accelerate, right? You get the input from the control system, the speed of the vehicle. You try to match the speed of the vehicle with the set speed. Right? So you have mechanics involved, you have controlling involved, you talk to the throttle and control, and you will be accelerating, decelerating, braking, everything gonna be included. So it's basically looking into setting a speed, like constant speed. Usually it will have like plus or minus. And you can gradually increase the speed as well with acceleration and deceleration. Right? So we see here like acceleration. Let me get the laser point. So you have see acceleration, deceleration. You can reduce the speed and you can set by pressing this button. Later on, you get it on the steering wheel itself, right? The cruise control. In my opinion, this is a good step towards a very good step towards automation or autonomous vehicles. The ability to control the speed of the vehicle. The game changer happens when it comes to like making decisions based on whatever happening around you. Right? So all this stuff that we saw so far, except for the fact the rain sensor or the wiper, autonomous wiper system, which would be looking into an external input, which is the rain. Not a human generated, but the nature generated one. So nature generated one, easy to predict. I mean, not predict actually, it is easy to detect. It is a reaction based on the detection, not prediction. So autonomous comes in handy, or this name comes popular when we had these decision-making capabilities with prediction, not with observation. Yeah, with observation, but not solely based on observation. Right? With some calculation, with some prediction. Even though some numerical calculations needed to be done for determining the speed of the wiper, or in fact for turning on the wiper as well, the technology most of the vehicles use and using is the reflection technology. You have two lights, and then the reflection from the glass panel in front of the vehicle or the windshield glass, that will change when you have rain droplets. So the reflection coming from the glass panel will change based on whether you have rain droplets on the windshield or not. So based on that, you take the decision. So numerically, what you see in the sensor, I mean, in terms of processing, what you see in the sensor, like sensor input, is a numerical value or voltage. Right? In today's world, you will do digital processing and make a decision. In that sense, what you will be dealing with numbers, right? Yeah, you numerically you make the decision when it's raining or not. So that I'm not going into kind of talking about that type of numerical analysis here. When it comes to autonomous emergency braking, it's about human related interactions or human related changes in the atmosphere or in the surroundings, or it could be animals, right? It could be another vehicle. I mean, another vehicle, speed change, things of that nature, or coming from a crossroad of that nature. Those all those things would be human generated, except for the fact that if you have an animal crossing the road or coming towards you, or a bird flying or whatever, right? So that type of a situation is not a human generated. It's kind of another way around. So coming back again, the difference between the autonomous part and then you just have these automated parts, right? There's a slight difference, right? A slight difference. So in autonomous part, it's kind of automation, but if you have that intelligence factor. So that intelligence factor will not be generated by the vehicle itself. I mean, you have to program as people who will be involved in electronics, computing. You have to do this programming, right? You have to do this training. So that training part, the AI part comes in, right? Comes into action. But if you look into autonomous emergency braking, it's not heavily, I mean, AI related. If you just get to the scenario where you have autonomous emergency braking simply to avoid a collision between your vehicle and the vehicle going in front of you. I mean, by braking, you can avoid that collision. But what if the person coming behind you kind of trying to hit you with a high speed? Then either you have to accelerate or you have to change the lanes. You have some options, but we will look into those, right? So the simplest scenario, it looks like not AI involved. I mean, you can do by simple coding, simple arithmetic, right? Arithmetics, like simple mathematics, right? Simple calculations like speed and displacement. But even though it's simple, you have to do some analysis, isn't it? You can do some braking, but when to brake is the problem. Like when to brake and at what level. So in modern day vehicles, you have these pollution warning systems and then autonomous braking as well. So first, you will get kind of a warning. In most of the vehicles, then your steering wheel would be vibrating to indicate the driver, hey, I mean, there's something going wrong, just look into it, right? That can happen for a lane departure warning as well. If you have lane departure warning enabled, if your vehicle is not going between the lines or in the lane, right? If you are trying to move away from the lane without turning on the signal light, then the system will think you are maybe dizzy, maybe you are kind of distracted by a phone call, or a person might be talking to you, might be you are thinking, maybe you are dizzy, maybe you are sleepy, right? So that the vehicle is going to the other lane, right? If you don't have this uh, signaling, right? Signal light on, or any manual movement in with your hands, or the pressure given to your steering wheel, right? So there are many ways to detect whether it's intentional turn, or whether it's an intentional lane departure or not. So in a situation like that, even in the collision warning, your steering wheel might be vibrating, or maybe you might get a beep sound depending on the manufacturer or the type of the vehicle. Once you get the collision warning, if you don't react as the driver, then the automatic braking will be engaged, right? So you should determine as the manufacturer of the vehicle when to have the warning and when to start braking. Right? What is the gap between how much of time that you are allowing? That time that you allow will depend on the speed of your vehicle as well as the speed of the leading vehicle or the vehicle in front of you, right? Basically, it's about your vehicle speed and the approaching speed, right? The relative speed of approaching. Based on that, the time you give for the warning as well as for the first stage of braking, second stage of braking, could be multiple stage of braking, and then full braking, right? To come to a full stop, right? That's not that easy as we talk about, right? Because that braking might need to happen simply because you are going at a much higher speed than the leading vehicle, or maybe you both were going at the same speed, maintaining the same gap, but all of a sudden this leading vehicle braked. So how do you know it braked? With the displacement sensing, right? You are approaching very quickly. Now, how do you know whether it is stopped? That you are the one only who's moving. That is again by taking the displacement and the speed. If the speed and the time it took is matching to the displacement 100%, then your leading vehicle is stopped. And another way to realize whether your leading vehicle is going to be braking, right? That is with the brake lights of the leading vehicle. So it's not about just looking into the displacement, right, or the distance between the two vehicles. It's not only about just looking into the speeds, you have some other indications as well. So that is where the things getting complicated, right? That is where the things getting complicated. So when we move into the next level of cruise controlling, right, we call it as adaptive cruise control. So in adaptive cruise control, it's not just you set a particular speed and then you just wait, right? In normal cruise controlling, it will just keep the speed, right? But in adaptive cruise controlling, and in normal cruise controlling, if it cannot maintain the speed, right, or if it just drops below the speed, I mean, you have to manually tell, right? You have to manually disengage the speed. So in traditional or the initial cruise controlling, once you set the speed, if you fall asleep, that is really dangerous, right? Because the vehicle will try to maintain the speed. It will not be taking the turns for you. It will not be taking um, the maneuvers for you. So it will not. If you come across a cow or something, I mean, it will not stop. I mean, it will. If you are being, you tell it to go in that particular speed. So normally the cruise controlling is used in highways, right? But still, if your vehicle in front brakes in normal cruise controlling, the earlier stage cruise controlling, it will not stop, right? It will not slow down unless you tell it to slow down. For example, if you press on the brake pedal in traditional or the conventional cruise controlling, then it will disengage the cruise controlling mechanism, and it will no longer accelerate and try to maintain that speed. The moment you press on the brake pedal, it will disengage the cruise control, right? In adaptive cruise control, however, you set the speed, but if it cannot maintain the speed, then it will take action. Right? It will detect what's in front of you and slow down. Right? When it is allowing you to go reach to that speed that you have already set, then it will again accelerate and try to maintain that speed. And it will look for the safer distance as well. When you look for the safer distance, it's not just about your car's capability, right? Whether you can accelerate, decelerate, especially when it comes to braking, right? It is about the ability of braking of the other vehicle as well in front of you. You may be having super brakes, and also you have to look into the vehicles coming behind you. That's another thing. So I was talking about the decision making of braking and the cruise controlling, the advanced cruise controlling or adaptive cruise controlling. So initially, cruise controlling was like you set the speed and the vehicle would maintain the speed. Now, with adaptive cruise controlling, the vehicle has the capability to look into the conditions of the surrounding, right? And based on the surrounding conditions, the vehicle can slow down when it needs to be slowed down to avoid collisions, and when it's capable, it will try to reach the speed that you have already set. So that's the next step. So this autonomous vehicle scenario is not just one day thing, right? As you can see, and as I have shown you, even these small steps in terms of automation, like not having to have a human interaction stuff, has happened in the industry, have taken these autonomous vehicles into the next level, right? And I would like to kind of touch these the touch points or the basics first, and then we will look into where we are today, right? Don't worry. So we will go to where we are today in terms of technology, as well as where are we? I mean, how far are we away from that imagination that we had at the beginning, right? You might have had a different imagination, and I showed some images as well, right? How far away we are, right? um, we will look into. Okay. So if we look into this adaptive cruise control, I just mentioned about the vehicle in front of you slowing down, and it's not just about the measurement of the distances. Like you can use sonar, you can use. I mean, if you have these Arduino-based toy vehicles, you might have infrared sensors, you might have ultrasonic sensors, right? Mainly, you would use ultrasonic sensors to measure the distances, but what type of sensors are we using to detect the displacement of vehicles? I'm pretty sure you already have some idea, right? Um, but is it only about the displacement, right? That to determine the braking? No, isn't it, right? The amount of time it would take for a collision, it depends not only your speed, right? It depends on the friction your tires would be having with the road in terms of the stopping distance. The stopping distance will differ from the road surface to road surface. And for the same road, it will differ based on the weather conditions. Right? There could be some ad hoc scenarios like oil patches. Right? Those are ad hoc scenarios. But when it comes to autonomous vehicles, if there was a collision, all the blame would be to the manufacturer. But if it was driven by a driver, the blame will be shared. Mostly the blame will be going to the driver. Right? And in some scenarios, yes, the blame will come to the manufacturer of the vehicle as well. But the manufacturer of the vehicle cannot survive, right, without taking the blame if there was any accident happening in an autonomous vehicle. So that's another thing why it is taking so long for autonomous vehicles to come into the market, right? Because the manufacturer has to take the full responsibility. So it has to look into all these aspects. There could have been an oil patch. Right? If there was an oil patch on the road, I mean, yeah, you can tell we have not manufactured for that type of situations. But what if you could, right? Then how could you do that? Then you need to have some image processing in it, right? Not only that, right? As I mentioned, you have to consider the weather factor as well. There could be muddy puddles. There could be slightly dampened roads where you engage the brakes, but it will not be stopping. The stopping distance might be very high. Maybe you will be skidding. For that, yes, we have anti-brake system to avoid the skidding problem. Another step towards autonomous vehicles, even though it is really helpful for the drivers as well in terms of detecting detecting abnormalities and adapting the braking accordingly. And in terms of stopping distance in adverse weather conditions as well as other adverse situations. Right? There are rollover avoidance, skidding avoidance. Likewise, so many technologies are already built into manual driven vehicles as well that paves the road towards autonomous vehicles. So we will not be touching each and every aspect of the development, but we will be looking into few critical ones today. So if you look into adaptive cruise controlling, yes, not only this distance is enough, we would look into the brake lights engaging to give a smooth ride to the passengers or the occupants. Right? Very important, a smooth ride. When it comes to autonomous vehicles, for that matter, vehicles, it's not about just you be able to go from one point to the other. It is about you take your passengers, the occupants, from one point to the other with comfort, with safety, and with reliability. It's very important. So, as manufacturers, as people who are designing these systems, you have to look into all these aspects. The efficiency is also important. And you can have the autonomous vehicle that would be going really slow, avoiding all the obstacles, but nobody would be buying it. Right? So the efficiency is also important. The practicality is also should be looked into. When it comes to the comfort, identifying whether the vehicle going in front of you is gonna brake or not, whether it's gonna be stopping or not, it's gonna be slowing down or not. Identifying it as early as possible is very important. So one way to do that is the brake light. So you will be having a distance recognition system of some sensors for that. And then you will need to have some sort of image processing capability to see whether it's going to be braking. So remember, this is not that easy because if you are driving at night, now you cannot say that the autonomous vehicle is only be operable during the daytime. So if you are manufacturing an autonomous vehicle, highly likely you have to have you have to design it in a way that it could be operable at night time and the daytime and in adverse weather conditions as well. I mean, if you're saying that okay, your vehicle is not capable of being driven or being operative in the rainy days, then I don't think many people would be interested in buying your vehicle, right? So you need to look into all these aspects. So it's not that easy. So I told you all about the wiper system, right? So you have a camera, so normally it's behind the windshield, right? So those cameras, those should be having a clear view, not only during the daytime, even at night time. So highly likely you need to have infrared cameras for that matter, for that aspect. Maybe you will be processing with daylight, with the colors as well. But at night time, yes, you will process with colors, but you should be having some other capabilities as well. But simply looking into cruise controlling only. But if you have cruise control, adaptive cruise controlling, you should be taking care of pretty much all the collisions that can happen. It's not about just the vehicle going in front of you. What if a person comes in front of you? If you have a proper adaptive braking system, then it should be able to brake and avoid the collision of a human or an animal. Any obstacle for that matter. It could be an object. Probably somebody had these supermarket carts, right? Uh, Maybe somebody just were packing the car, right? Taking goods from the supermarket cart, packing it or putting it into the car. All of a sudden, without his or her knowledge, the supermarket cart moved around, right? I mean, just kind of went out of control or just started moving without that person's knowledge. It might come and enter a main road. Who knows, right? So your car or the vehicle should have that capability to avoid that, either to maneuver around it, or in this case, what we were talking about, braking, right? So now you get the idea. Braking is not the only avoidance technique. Maneuverability is also another method, right? If you cannot, there are situations you cannot brake and stuff. For example, if a child kind of like these things happen, right? Kids play, right, when for example, let's say they play cricket, right, and the ball goes to the road. All of a sudden the kid forgets that, I mean, he or she is in the middle of the road and just get to the road. All of a sudden you have to brake, right? But the distance between your obstacle and the vehicle may not be enough to brake and avoid the collision. In such a situation, are you going to take a left turn or a right turn while braking or without braking? Are you going to accelerate and avoid it? In some situations, yes, you'll have to accelerate and avoid some collisions, right? Not decelerate. So you have to take sudden decisions. So much of computations. Um, as a driver, you take these type of decisions every day, but do we have that sophisticated electronics to do that in modern day? So coming back to this autonomous braking, this type of braking, the next level braking, predicting these sudden appearances of obstacles, we call them intelligent emergency braking. So we do have that technology right now. Is it at the top level? It's almost at the top level, but still further developments are going on. Especially, how fast can you make the decision? Like how fast can you make the decision, and what type of obstacles can you avoid? Currently, targeting on humans, we are in a super duper level in terms of detecting humans and engaging autonomous braking. But still, we are in the process of avoiding pollutions which cannot be avoided simply by braking, right? Simply by braking. Remember another number of parameters you have to consider. You see the obstacle, you have your braking capability, and you saw that there are different levels of braking. In an emergency situation like that, highly likely you might think you will be going to straight away this level, full braking. Not at all. If you go full braking, the damage could be severe, right? For example, you might be having somebody crossing the road in a crowded environment. You're gonna have the full braking, your vehicle will go out of control. Whether you drive as the driver or whether it's gonna be autonomous, there are mechanical capabilities in a vehicle, right? So if you engage full braking the very first time, you will go out of control. Your brakes might get locked as well, and you might go out of shape. You might topple, right? Your vehicle might topple, swivel out of control, and you might hit not that one person, you might kill 15 people sometimes. So it's not just one decision to make, whether brake or not, right? It's not just about whether you are going to kind of avoid the collusion, right? It is about you knowing your surrounding and trying to make the minimal damage, right? So that is the ask in the industry. It's not that somebody comes in and you break it and stop, or you feel so good, right? Right. I mean, you just stop and you save everybody. That's good. But if you just save that person and kills another couple of people, or just um, kind of damage them or damage other property. Like if you talk about life and property, yeah, damage the property, forget about that, and then uh, save the life, right? But you have to have apples to apples, right? You get it, you have a human, probably child, and you might be having couple of other children, right, in the surroundings. If you make a manure, like to which direction are you going to take the manure? So you should be always observing, and you have to get 5 seconds of a decision. Right? So that's the ask. So you have to do that, not for only that, while adhering to your laws, right? You have to look into adverse situations. You have to look into road signs, right? And that's not easy. That's why we go through like machine learning, AI comes into action. It's not just simple electronics or sensors talking to microcontrollers and then controlling stuff, right? So you need to have advanced decision making, right? So called AI powered decision making. So you have complex traffic scenarios. We already discussed a few. Right? It's not the only stuff. And you need to predict humans, animals, object movements, right? And you need to look into road conditions, weather conditions. It's a mixture. So these machine learning models or these AI tools, they will get so many inputs, so much of data, and mostly we have to do some image processing. It's not as simple as just looking into a brake light whether it's gonna be red or not. I mean, that's easy, but it's more than that. You know it now. The human might be not directly appearing, the face might not be visible, you might be seeing side of the human, animal might be at different angles, even the signs, right? We will see a few examples. They will be in different orientations. But training, you have to do a lot of training, right? It's not just about doing a lot of training. I mean, you can do a bunch of training stuff, but if the decision making takes like maybe 1 or 2 seconds, that adds up to that decision making or the reaction time, which would be like whether that's the decision of whether saving a life or kind of killing somebody, right? 1 second is huge when it comes to highway speeds, right? It's huge, right? So you need to have split second decision making capability. With image processing nowadays, so people who are into image processing, you know how much time it takes for image processing, right? So imagine as we go on with this talk, right? How you would be doing this image processing, not just one, right? Many within the given time frame. It's not a minute, hour, right? It's gonna be a fraction of a second we are talking about. You have to make these decisions. So that's the ask that we have in the industry today, right? Might think, oh yeah, I mean, we have algorithms to track the vehicles, and boxing, and then you have tagging. You can follow that path, and everything is there. This is real time. What is this person talking about, right? uh, how long will it take to detect this? Right now, this is in a highway. Imagine some sort of an animal like a deer come process. I mean, this is a huge problem in countries like United States. Deers getting into the highways. Right? The damage is significant, fatal. People die. Right? And when you have to make decisions. I mean, are you gonna slow down? If you slow down, sometimes the damage can be fatal. Right? If you cannot avoid the hit, right? And some other instances, people try to avoid the deer and go and hit a tree. Again, the damage could be significant. In some instances, people get the damage but accelerate and hit the deer, and the deer goes flying over your vehicle. The damage to the vehicle is minimal. So avoidance of the hit is not the target, right? The target is the minimal damage. So you should have an idea about the domain if you want to design autonomous vehicles, right? Autonomous vehicles, we will discuss this later. You might think it's about the safety of the occupants. No, it's not just that. We already discussed that. It's about the safety of the occupants. When you are trying to purchase an autonomous vehicle, most of the time I would say it's about whether you can protect your family, whether it is kind of safe enough. But in terms of society, it's not about the occupants of, it's not the safety of the occupants only. It's not just the comfort of the ride. It's about how safe are they to be on the roads. So that is the major challenge right now in autonomous vehicles. So let's look into this image processing thing. I mean, image processing is really challenging, right? It's really challenging. I mean, you get all the road signs and then you train it, right? Then it should be making decisions, right? But it's not that easy because your signs may be of different angles and of different shapes and different notations in different countries. Yes, of course, for the country, you can have that learning package. Why not, right? You cannot have, you should not be having all the image processing capable, I mean, ability to identify all, I would not recommend that, all the road signs in the world for that, for a given vehicle. Right? Should not be doing that because if you try to do that, theoretically, the decision making time will increase with a fraction of a second. Again, fraction of a second delay, even if it's 1 millisecond, that delay is a life and death scenario, right? I mean, it's kind of the difference between whether you avoid a hit or whether you kind of just go through the hit, right? So if you should not be, in my opinion, you should not be training for all the signs in the world, but the signs that would appear in the context of where you will be using the vehicles. You should have that ability to upload that package. For example, if you are having a European car for Europe, you should be having that Europe package. If it's only for one particular European country, you should be having that for that particular European country. You should be having a set of signs, or else you should be having a global set of signs, right? So that's what we are kind of in right now, right, in terms of global acceptance. So again, coming back to training images as well, it's not just you look into a set of all the available signs in that particular country or region or in the world and just training for them. We have these ad hoc scenarios at different angles, and you might get glare from the sun, right? So you should be expecting all the stuff. And some signs might be in a shady area, and some I will show you some images. Okay, don't worry. Right? Some might be in very lit area, very well lit areas. Very importantly, these road construction situations, that is very challenging because road construction, it's sometimes the placing of the signs is not normal, and also it is not a regular scenario, isn't it? For example, let's say there was an accident, right? Then you have to detour. In a situation where you have to detour, as a human, yeah, you read the signs and you take decisions, you can ask from somebody. Right? For autonomous vehicles, there's a workaround, that is the maps. I mean, even Google Maps, you will get detours if you have heavy traffic, right? If you have an accident, you get the detour option and you can follow that. Right? So one other aspect of autonomous vehicle becoming a reality is having very informative maps, right? Responsive maps that you can guide and fine tune towards autonomous vehicles. So many of these decision making capabilities or decision making scenarios can be avoided if you have very detailed maps where you can feed in data and communicate with the map. But you cannot simply rely on real-time updating of the maps. For that, you need to look into the communication systems as well. So we will get there. Don't worry, right? We will get there as well. So when you kind of join this particular talk, you might have thought about, okay, we'll learn about autonomous vehicles, maybe what are the latest trends and all. Yeah, but autonomous vehicle latest trends or becoming a reality is not just about the vehicle itself, right? So right now we are introducing the capabilities of the vehicle that it should be having. So let's look into some scenarios that I spoke about, the ad hoc scenarios that would be complicated, not for a human, um, but for an autonomous vehicle. Right? So people holding, yeah, okay, this is an obstacle for the autonomous vehicle. I'm just going to give you the perspective of the autonomous vehicle, right? Um, so yesterday the autonomous vehicle drove on the same road. This obstacle was not there. All of a sudden you have an obstacle. Now this is a really small obstacle, right? You need to detect that one as well, the distance to that particular pole. Otherwise you will be hitting this, right? Your vehicle might not be like as high as this if you are driving a car like autonomous vehicle. If you cannot detect this obstacle up to this level, this accuracy, this is about the resolution, okay? This is about the resolution, right? If you could not detect this, then that would be a problem. Right? You should be having that capability of detecting these tiny little obstacles. And then you see another heavy obstacle here, so you should be waiting. And yes, it's the stop sign says, yeah, wait. Yeah, I mean, this is easy to detect because anyway you are being trained to detect a stop sign. Normally a stop sign would be kind of hexagonal shape, but here sorry, octagonal shape. In this case, you will be having kind of a round shape. So have you trained for a round shape stop sign? Yeah, maybe yes, you can do that, right? And when you look here, there are some signs with text and then numerical values. Yeah, we will be training for this, but have we trained these to have these together? Yeah, nowadays they can handle it, right? Can you detect the cones? Yes, nowadays autonomous vehicles can detect the cones. But if somebody is giving directions, right? If somebody is giving hand gestures, we are up to a certain extent. I'm not 100%, like 90%, I would say 85%. We are there, right? To identify hand gestures of people who will be giving instructions. But you need to think about it. Just think, imagine how much of training that should be going there. It's not just image processing. Sometimes when it comes to hand gestures, you have to get the sequence of images and then process what is the direction that this person is kind of indicating. Right? It's not that easy because these people might be in different angles, and your camera in the autonomous vehicle might be capturing different angles, right? So you have to go through rigorous decision making. That's why these ad hoc scenarios are very difficult to handle. And you have to look into these hand gestures while you are looking into other signals as well. I mean, other signs. So that is the difficulty. It's not just about reading one particular object and determining, right? Now this one says like go in between the barriers, and then this one says okay, it's like bidirectional traffic, and this one says okay, there is a work ahead, right? I mean working area is ahead, and this one says okay, use I mean this lane, and you see bunch of stuff. Remember, what you capture from a 2D image is 2D. It does not have the third dimension, the distance, right? How much distance is this and this? I mean, is it far away from this? You need to identify with AI. That needs considerable processing, right? By the looks, if they were of the same size, then yeah, you can guess. But what if they were not of the same size, right? Not of the same type, right? So decision making is not that easy as we think, right? So many signs. And this is nearby an entrance to a highway, right? It has some information. Now in daylight, yeah, you can tell this is green. Okay, this is about information, and this is about highway sign blue, and this is about the previous type of or the state symbol for the highway. And all of a sudden you have do not enter. I mean, obviously, I mean, no one can enter here, isn't it? Right? There's a barrier. It's not about do not enter to this area. This is talking about do not enter to this. I'm pretty sure, right? Or else it might highly likely this do not enter is for this area, right? For this. Um, Let me use the annotation tool and use the laser pointer. Right? Highly likely do not enter wrong ways to this path. So as humans, even we struggle to determine, okay, do not enter to which area, in which lane. As a person, I have struggled, right, to determine what these signs mean, right? Especially when I was in the US, right? Do not enter, it's a kind of known thing. It's really hard to determine which sign is for which road, right? So if humans struggle to determine that, how come the cars determine that, autonomous cars? Again, the solution is very informative maps. Right? Even though we struggle, if we have, even though we struggle with the science, if we have these well-informed maps, then we can avoid those do not enter scenarios, right? And many other scenarios like one-way road, right? Bi-directional roads, if all the information are there. But the problem is, right, when we have construction sites like this, will the map be updated? Now that is infrastructure development. You need to have the maps up to date because in construction area there could be priority lanes, right? For example, here the sign says, okay, you are moving ahead, but the priority should be coming to incoming traffic. It might be narrow road. If you see somebody coming in there on the road, you have to give that person the chance. For now in Sri Lanka also we see this when you go around places, we may have narrow bridges, right? You cannot have two vehicles crossing the bridge at one point, right? At a given time. Um, no two vehicles in two different directions could kind of pass. So in such a situation, the other person has to stop. They have to look whether someone has already entered the bridge, and then they have to stop and wait till the other person passes. So that type of a situation will be there in construction areas as well. Or that type of a situation might be there in a normal scenario as well, as I mentioned, near a bridge. Right? Can autonomous vehicles handle those situations? Right? Of course, I mean, it should be able to handle um, if it could see the incoming vehicle clearly, right? If not, what it's gonna do, right? Um, One scenario would be both vehicles might come together, right? Let me get the annotation too, right? So here, if you have a bridge, if you have a bridge like this, right? Let's say you have a vehicle coming in from one side, and they did not recognize another vehicle also coming on the other side, right? Moving towards this direction, right? And the other one moving here. So what should they do now? I mean, they encounter it, they know that you can't pass, then probably both might be reversing or backing up, right? I mean, both might have programmed, okay, if you see an obstacle, then, you just stop. Normally, you programmed to stop, right? Brake, and both will brake, and no one will be able to move, isn't it? Right? So how to address such scenarios? I hope you get what I'm saying, right? Just imagine this is a bridge and that the two vehicles cannot pass each other if they were moving like in the opposite directions. And once you encounter, if you have trained that vehicle to kind of, if you have an obstacle, just stop, right? If you cannot move like left hand side or right hand side, you just have to brake and stop. And both the vehicles might be trained to do that, so that there will be a block, never ending block. We say like deadlock, right? Nobody moves, nothing happens, right? Or else if the waiting time is a little high, then you might be able to like kind of back up. But during that time, there might be another vehicle, right? Another vehicle might have already come if it has not seen this, right? Now you cannot back up, right? If there was another vehicle here, you cannot back up as well. Now all those things should be backing up, or at least one side should be backing up. Actually, one side should be backing up. So prioritization. And with that, another thing comes up. The inter-vehicle communication is important as well. Otherwise, this type of a deadlock cannot be avoided, isn't it? Right? Because you have trained the vehicle. If you cannot kind of move forward, you just stop, right? I mean, if you have an obstacle to avoid the collision, and both will do the same, right? Nobody moves. So intercommunication capability is a key, right? Is a key. That's the future moving forward. And everybody should be able to communicate with pretty much the same protocol. That is the challenge here, right? All the manufacturers will try to kind of, outsmart the other manufacturers to try to have the most latest technologies and so on. But if you cannot communicate among the vehicles, it's not about, let's say you have a brand ABC, right? Let's take known brands, let's say Mercedes Benz, BMW, right? Audi, for all right. You can say Nissan, Honda, Toyota, Tata, right? Whatever it is. I mean, if they have their own communication protocols, okay, Toyota vehicle communicate and identify whether who should be given the priority. Honda vehicles, they just communicate. Audi and Audi, they communicate. That's not enough. Volvo, no, that's not enough. You should have a common protocol where everybody should be able to communicate with everybody, right? So that is a big ask, right? That is a huge ask for autonomous vehicles to become a reality, right? If you look into other scenarios again, like there could be new signs coming in, right? The moment that you have a new sign, yes, with the image processing capability, you should be able to recognize, but there could be some other changes. So if that change happens, then you need to run the machine model again, right? I mean, your car you have to program it again, right? And on top of that, you might be having, as I previously mentioned, bunch of signs to make decisions on, right? Bunch of signs, not only one, right? You should be able to read bunch of signs and also take actions accordingly. If it's slippery, if it's a rainy day, you have to be precautious, and it should be communicated to the car control system or the stabilization system, and then take actions, right? If you can recognize and communicate with the stabilization system, modern day stabilization system can handle those. I mean, shock absorber tuning itself, some modern high-end cars, you can do shock absorber tuning as well and handle the vehicle to handle slippery situations, slant, slopey. Uh, if you are moving along a road which is having a high or very steep slope, right? Or things of that nature. And here, so let me kind of show you a few things. Um, let's look into this, right? The sign is covered. Are you training for those, right? There's a hump. The speed limit is 30. You can't see that it's 30 or 35. Okay. So what are you gonna do, right? So image processing itself is not the answer. So that's the idea. Right? As I mentioned, the maps should have this information, right? Very informative, detailed, precise location, right? With the precise location of the sign and the hump itself, you need to have. In the Sri Lankan context, it will be really difficult. Okay, it's not only humps. You have these ponds, right? Puddles. You have these holes in the road. So if you go today, yeah, it will be good. But if after the rain, it might be kind of a collection of potholes, right? So you need to kind of have the potholes in the map as well. It's a very it should be a demanding job in Sri Lanka. I mean, if we go like these conditions, like the quality of our roads. I mean, if we are going to have this type of quality, especially in urban areas, not in city areas, it's good. Urban areas, not that good. In village areas, some areas is good, some areas is really poor, right? So not only the harms, even these ad hoc scenarios, you have to, have well documented, I mean, well informed, especially in terms of the map. Map should be really informative and it should be up to date. Right? These type of signs, these are critical. Stop signs. I mean, if you don't see the stop sign and if you just violate the stop sign, then you might be hitting with another vehicle, very high chance. Especially in this time, in this era, where you have autonomous vehicle trying to get into the market while the manually operated cars are dominating. That is the challenge actually to the industry. If everything is autonomous, I will show you. I mean, you will also get the idea. When everything is autonomous, the challenge is actually minimal. All you need is those autonomous capabilities, the detection capabilities, the ad hoc scenarios, adaptation, especially detecting humans, the obstacles, moving obstacles, then detecting when it becomes a threat, whether it would become a threat, and how long do I have to react and how should I react and so on. Right. So those are the critical challenges in terms of the technology. In terms of reading the signs, actually, it will become obsolete, in my opinion, down the road. If every vehicle is gonna be automated, autonomous, it will be about informative maps, right? So these scenarios, I mean, again, I mean, these will become obsolete. So this could happen due to a heavy wind after a cyclone, right? Um, so you cannot heavily depend on these signs. So that is uh, what you should be taking as the take-home message from this slide, right? Reading signs again, it's not that easy, right? I mean, you just see how many signs are there. It's not that the clear vision you are getting. You may be training for a clear shot, but those signs might be covered. We saw in the previous slide as well, right? Covered by different obstacles. So can your model recognize these signs with these obstacles? It's not just about can. How fast can you make that decision? How fast can you identify what it is, right? When you have bunch of signs, which mean some signs may not be traffic signs as well, but as a processor, you need to process everything and determine which one is a sign. And then I mean, at the same time, you have to determine which sign is this and what does it mean and what should I be doing? I mean, should I take any action at all? And so on, right? So how much time do we have to spend and how much processing you have to spend? I mean, if you have really informative maps, maybe we can work around. But signs of this nature, you cannot 100% get rid of because you need to have these type of signs for the pedestrians. We never know. I mean, whether we would be coming up systems for the pedestrians as well to realize these type of signs. Maybe with artificial intelligence enabled glasses, probably you would see where to cross the road in 20 years time. Who knows? Yeah? Let's have the fingers crossed. This right hand side image actually is from um, September 11 attack scenario. So New York City goes to all traffic. So can your autonomous vehicle detect that kind of a sign? Maybe a road closure in front because of an accident? Can your autonomous vehicle detect this type of sign? which are in words and determine what is it about. Do you really need it? If you have that informative map, you don't need it. Because in the informative map, if you have real-time update, you can update the weather, you can update pretty much everything, right? But it may not be accurate, right? Weather might change rapidly and very quickly. And so you may not be having weather sensors all the places to update everywhere, each and everywhere in the run, right down the line. So you need to have weather sensors in your vehicle or communicate among the vehicles about the weather conditions and so on. So we will discuss about those things a little bit. So when it comes to signs, it's not about the road signs that you have on poles or on hangings, right? You have to look into the road signs on the road as well, right? On the surface of the road. And obstacles like this, I mean, there's no obstacle physically. You can go even from the middle in this situation, but it says, okay, you mean, just have to go around. Right? This is a roundabout, right? So if you detect a fallen tree, probably nobody knew about it, right? Because you are the first person to cross the road and there's a fallen tree. Can your obstacle avoidance system avoid it? Highly likely, yes, right? Because we have sophisticated sensing systems we will look into very quickly. All right, in a situation like this, recently in Dubai, we saw that in media as well, right? Will this type of a flood cover your sensors in the car, in the vehicle? Right? Something to question about. You have so many electronics, will this type of a flood destroy your electronics? We have to address this. If your autonomous vehicle to be real reality, right? If the dream that you had, the dream that we were talking about right at the very beginning, in the very first slides, right? The dream, the future of autonomous vehicles. And we need to look into different contexts, different scenarios, different ethnic situations, and different countries, different laws. In some countries, you have to have at least 3 feet gap from a cyclist, otherwise, it's a violation of the law, right? So you have to adhere to the law as well. So your autonomous vehicle should not only know about reading the signs, but should know the law as well. Right? It's going to be a full package, and you need to analyze the law when you make the decisions. So we need data, right? So yeah, car can take decisions, but to take decisions, you need data, and you need it in real time, right? You need most up to date one. It's not like yeah, you can have a map, but it should not be an outdated map. You have to have all the stuff up to date, right? You can get data from pretty much everywhere. And if you look into data gathered from the vehicle itself, you will have a bunch of sensors. Right? You might have seen this type of vehicles, like this is the Google car, not manufactured by Google actually. Like so here, it's a Toyota Prius, as you know. I mean, pretty sure that you know it, right? Early models, right? I think this is 2014 somewhere around, yeah. So Google car, or 10 years old. Technology. So you have a LiDAR sensor here. You just capture what's going around, and literature says they have covered more than like 100,000 miles in this vehicle in the state of California. So you need to make advanced decisions, right? It's not just about avoiding collisions, right? It's about lane changing. Is it safe to change? For example, in this scenario, you gotta, I mean, it's safe to kind of change the lane towards the left-hand side of this particular vehicle. I mean, if it's traveling towards our left-hand side, but in terms of the vehicle itself, this vehicle, it's okay to go forward. Okay to go towards the left-hand side, but it's not good to take a right turn or lane change towards the right lane, or kind of have a sudden stop, so that there could be an easy collision with the rear vehicle. So what needs to be done is, it's not about like just looking into the front, right? We were mostly looking into kind of up to so far, we were looking into the road signs coming ahead and everything. But it's not just about looking ahead, right? The dominant factor would be looking ahead of where you move on heading to. But you need to look into the other factors as well, right? You need to look into the surroundings, okay? And for that, we have a bunch of sensors, right? We have adaptive cruise controlling. For cruise controlling, we have long range radar. And for emergency braking and pedestrian detection, we have LiDAR. And then parking assistant, and we have ultrasound. And then you can have short and medium range radars for object detection, like sidewise as well as the rear end, the collision warning, blind spot detection. If somebody is trying to overtake you, you might have seen these are kind of already developed stuff. Okay, now these are already developed stuff. So all will be giving inputs for autonomous vehicles to make data-driven decisions, right? So normally we would call it AI, right? Artificial intelligence, you make decisions. The key thing is real-time decision making, right? That is the key. Okay. So I'll be we have about another 20 minutes, so we just kind of try to touch different aspects. So if you look, you saw here LiDAR, and I used like the previous one of the previous slides as well. I told LiDAR sensor is there. So why LiDAR? Huh? So we could have used sonar, yeah, to detect a displacement. So LiDAR also will detect displacements to different objects. But a LiDAR is sharp. You can get precise controlling. Can you remember? I mentioned previously as well, if you cannot detect this pole, it's really not easy to detect. You can easily miss it. Then you might be hitting this pole, right? You cannot do that, right? You have to look into the safety of this person and safety of the passengers, and you should not be damaging the vehicle as well. In an autonomous vehicle, if you miss something and hit, then you will be damaging the sensors as well. So it will no longer be drivable. Take that seriously, right? If you damage the sensors to a certain extent, then it will not be drivable. You'll have to call another taxi or another autonomous vehicle and then move on, right? So LiDAR is sharp, right? LiDAR is sharp compared to traditional radar systems. It is sharp, but it's not long range, but it is sharp. But another problem, even though the accuracy is high, LiDAR is very sensitive for weather, right? So if it's raining, it may not be that accurate. It may not work the distance that you would love it to work, right? So there are some caveats as well, and it's being used in not only in automation, it's being used in other, especially it is being used in mapping, right? Mapping situations, the displacements, these are sharp. The active readings are sharp, so accurate mapping not only in the world but outer space as well. LiDAR has been used extensively. So the game changer in this situation is if you come to modern day context, and you saw that LiDAR was existing in 2014 as well, we got in that image, and you saw the history of LiDAR as well. But it's not a new technology, but it has been developing. The accuracy improvement, the ability to adapt to adverse weather conditions have been improved. But the game changer here is the connectivity of data, right? So with 5G technology, the news is good, right? In terms of autonomous vehicle, the future of autonomous vehicle. The key point is the fast data transaction, right? You should be able to communicate vehicle to vehicle, right? Vehicle to vehicle communication, V2V, right? And vehicle to infrastructure, the signal lights, and if even weather conditions, right? And satellite, with the satellite also, we can get the satellite images, analysis, and then we can get weather data, obstacle prevention data, likewise. So we should be able to connect the vehicle to a network, probably internet, And then we connect the vehicle to the infrastructure and for the people, right? If you're crossing the road, probably, as I mentioned, if you have kind of, if you go kind of to an imaginary world or kind of predictive imaginary, I would say, like to the future, right? You might be, as I mentioned, like you might be wearing goggles or glasses that would tell you whether it's good to cross the road now or not, right? So don't be amazed. I mean, that will happen. That should happen if we go to the future that the automobile manufacturers are dreaming of. That is, cars, vehicles communicating with each other, just passing by, right? I mean, let's say a four-way intersection. One car might be moving this way, the other car might be moving that way. Like just that, as soon as it passes, like without even braking or stopping, with the speed adjustment, like vehicles might be moving, right? Even the interconnection, like intercommunication, object avoidance, like the vehicles, they talk to each other. If this vehicle sees an obstacle, let's say a flock of cattle crossing the road, then it will communicate to the other vehicle as well, hey, there's an obstruction, right? So that will be fast, right? And it will take actions accordingly, probably detour as well. And it should update the map as well so that others will know the central data gathering station. So basically, we are looking into a world which are interconnected, right? Everybody talks to pretty much everybody. So we call it like V2X. So we have V2V, vehicle to vehicle, V2I, vehicle to infrastructure, V2N, vehicle to network, right? Likewise, so all things together, V2X. And that's what we are now, right? But that's what we are aiming at. How fast can you do that? With 5G technology, it is promising, but the coverage of the 5G technology is an issue right now. On top of that, we are having research going on in terms of 6G technology, almost there. Need to address some security situations here as well. Another very important thing to consider is security of these networks, the communication, whether people can hack into the system and do all sorts of like bad things. Yeah, you crash vehicles and so on. Right? We need to look into those aspects. So the technology in terms of the speed and everything is there, but still people are working on the security aspect. Right? So where do we stand? Where do we stand in terms of the vehicle that we are talking about, the technology? In terms of the vehicle and the technology, we are almost there, right? We are almost there. It's but where are we in terms of the imagination of the future of autonomous vehicle? We are actually far behind. Actually, far behind. We need to address so many things before we get there. Right? To become an autonomous vehicle a reality, right? So many aspects to consider. Right? One important thing is what to do when you come across a situation, when you have a situation that you cannot avoid the collusion. We discussed this, right? Are we going to save the occupants? Are you going to save the pedestrians? Are you going to save the property? Let's say no occupant damage, no pedestrian damage. Let's say you can save the pedestrian by just hitting onto a pole, light pole, right? But are you hitting into the light pole? Probably it might be catastrophic. The light pole might fall down. The electricity might electrocute the people around. Or maybe even it might kind of initiate a fire that would kind of take towards several blocks. Several buildings might get damaged. And if it was near a forest, probably we are talking about a wildfire, which would kind of dominate and destroy many houses. Not easy decisions to make, right? So are you looking into the damage of the vehicle? And what about the loss, right? So, so many things to streamline. It's not just about the technology being there to take you from one place to the other. So that is the problem that we have right now. Taking from one place to the other is almost done, right? But we have to address so many things. Okay, so we have so long way to go. We need to get everything together. Automobile engineering, most of the stuff done. We need to find it. Communication systems, almost there. Interconnection is the issue. Infrastructure, a long way to go. Major investments need to be done, especially in countries like Sri Lanka, right? Even other countries included. Massive countries like United States, India, China, they have to put a lot of money because we are talking about intercommunication. Infrastructure building takes a long time. Ethics, what to do, what's the norm, whom to be saved, how to take the decision, and the laws needs to be changed sometimes, right? It's who's going to take the responsibility? You hit some person, is the owner of the vehicle or the manufacturer of the vehicle or the person who's giving the security updates? Is it about, I mean, autonomous vehicles? That's a question, a big question. Is it about the hardware or is it about the service? Is it a service or is it about hardware or is it about a product? Right? Big questions. Right? It could be service as well. Probably like internet service providing, connectivity service provide, security update service provide, right? And also about the public. Are we ready? Are we ready to accept autonomous vehicles? Are we afraid of like moving around in a vehicle without a driver? Right? So it's not just one thing. So it's an interdisciplinary approach. There's some sort of psychological aspects as well when it comes to training these vehicles. For example, different animals behave differently. If they see an obstacle coming towards them, some animals try to run away. Like they never go backwards. Some animals, they when they get panicked, they stop right there. Some animals they go backwards. Right. So it's not easy. It's not easy. So in terms of that type of training, yeah, still going on, right? Still going on, some work to be done. Okay. So my vision, my perspective about autonomous vehicles is, um, yeah, we already there. Semi-autonomic vehicles, we have to test it extensively, especially in highways, because these are really hard to test in city areas. First, you need to test in highways. Um, of course you have to first test in testing environments, but after that I'm talking about in real life, obstacles detection and stuff, test in highways, then the traffic is not that heavy, and then test in cities, right? And test in rural areas because infrastructure should be there, it's not easy, and then implement in developed countries, and then you can go provide adaptation, but simultaneously you have to develop the maps and the protocols to communicate, right? Very important. A common protocol to communicate. Otherwise, this will not become a reality. You can't ask one company to manufacture all these tasks, right? But everybody should be able to communicate with a common protocol. So that's very important. So beyond my vision, so I'm imagining day-to-day life scenarios, but beyond my vision, autonomous vehicle racing is there now and highly competitive. The future racing might be autonomous vehicles. So yeah, who knows? So with that, so I'm gonna end my talk.
As we come to the end of our session, I want to extend a heartfelt thank you to Dr. Jehan Senevirathna for sharing your expertise with us today. Your insights have been invaluable. Thank you very much, sir.
You're welcome. I hope you all got something out of it. Have a good evening. A good night. Actually. Bye.
Well, this marks the end of the session, and I hope you gain good knowledge from this session. I want to express my gratitude to each one of your participation and engagement throughout this session. Thank you once again and have a wonderful day. Good night.